Clap switch is an interesting hobby circuit which turns on the lights with a clap sound. Clap switch has the ability to turn on and off any electrical component or circuit by the clap sound. Components required for this project: 555 timer, sound detection sensors, mic, D flip-flop 7474, and finally, relay, 5 volts. The principle of the system is very simple. Condenser mic converts sound energy into electrical energy. This low signal will be amplified by 2 transistors and will trigger 555 timer. Triggering a 555 works as a clock pulse for D-type flip-flop and would energize the relay coil. You can connect any electrical device at the output, example a 220-volt bulb. This, the electronic circuit diagram and working of the clap light switch. I will explain each step of this project. Step 1. 2 transistor audio amplifier circuit explanation. In this audio amplifier we use 2 transistors which are BC547. The arrangement of Q1 transistor is collector to base biasing mode. This is through the 300 ohms resistance. The condenser output is fixed through the coupling capacitors. It is used to remove the content in the audio signals. The transistor Q1 will provide the negative feedback with the resistor. The output of the Q1 transistor is produced at the collector, which is the input of the Q2 transistor. The Q2 transistor is a fixed bias through the 10 ohms resistor and it is used for the further applications. Now we will see the result on the oscilloscope. The microphone signal is blue and the output signal of transistor Q2 is yellow. The amplification is made from 60 mV to 4.7 volts. Step 2. 555 monostable multivibrator. When a negative pulse is applied to the trigger input pin 2 of the monostable, the internal comparator detects this input and sets the state of the flip-flop, changing the output from a low state to a high state. This trigger pulse must be much shorter than the output pulse with allowing time for the timing capacitor to charge and then discharge fully. Output state until the time period set up by the RC. In the D latch, when the clock input is logic 1, the Q output will always reflect the logic level present at the D input. No matter how that changes, when the clock input falls to logic 0, the last state of the D input is trapped and held in the latch, for use by whatever other circuits may need the signal. And finally, we will explain the principle of the circuit of the relay. Is very easy. Below is the circuit of a relay driver using the NPN transistor BC548. The relay is connected between the positive rail and the collector of the transistor. When the input signal passes through the resistor to the base of the transistor, it conducts and pulls the relay. We will test the whole circuit. A weak signal is ejected at the input. When there is a clap, the lamp lights, and when there is another clap, the lamp goes off. Now we will test the circuit on the breadboard. Follow me, it's very easy.